My name is Chapan Rezang, and I'm an engineering graduate from Laurentian University under the chemical engineering discipline.
My name is Hassan Ishani. I'm also a chemical engineering graduate from Laurentian University.
Together, we're going to present to you the manufacture of ammonium sulfate from a smelter flue gas as a way of curbing the effects of the sulfur dioxide emitted to the environment. Sulfur dioxide is a toxic and global warming gas. It is emitted to the atmosphere via industrial combustion processes. The mining and petroleum industries are the major culprits of the gas emission. Now the focus of the project. We're going to focus on the sulfur dioxide from the copper and nickel smelting processes. The gas is emitted to the atmosphere during metallurgical processes of copper metal extraction. Using a charcoal pyrite as an example of the main ores, the oxygen reacts with the ore to produce the sulfur dioxide as shown below. The scope of the project is now to capture and react the gas with ammonium hydroxide to produce ammonium sulfate, which is then used in various industrial purposes. Now defining the problem. Gases from the smelter. The flue gas from the smelter contains a variety of gases, among which sulfur dioxide is the most dangerous. Now focusing on the effects of the smelter dioxide, they include acid rain. It arises from its reactions in the atmosphere with rainwater. The activity of the reactions increases along surfaces of structures due to the presence of metallic ions. Another effect includes contamination of water bodies, animal, and vegetation. The acid rain goes on and washes up into the water bodies and ends up accumulating in the vegetation and animals, which depend on such water bodies for water supply. Apart from the aforementioned effects, there's also been a positive correlation rather, of the sulfur dioxide emission due to the mining activities with the respiratory diseases. So we can therefore conclude that the sulfur dioxide is the main culprit of those respiratory diseases.
Now we are proposing a solution where the toxic sulfur dioxide is converted to a safe and applicable ammonium sulfate. So you might wonder why we chose ammonium sulfate. The reason is because ammonium sulfate is widely applicable to the industry. So some of the uses include it being used as a fertilizer, or it being used in neutralization of acidic soils. Also, it can be used to manufacture ammonium salt. Now, our primary interest is production or manufacture for mining explosives. Now, our entire process will be achieved by two principal reactions, which will be the reaction between sulfur dioxide and oxygen to form sulfur trioxide. Uh, a catalyst will be introduced to the reaction in the form of vanadium pentaoxide. The resulting sulfur trioxide will be reacted with ammonium hydroxide to get crystals of ammonium sulfate. Now, thermodynamic data shows that both reactions are favorable at room temperature. So only sulfur trioxide reaction is reversible. So it will be our limiting factor. So it has to be accounted for in the process. Now I'm gonna run down through the flow of our process. So we're going to get a sulfur dioxide supply either from a smelter or from a sulfur dioxide producing facility, and we'll react that with oxygen in a conversion chamber, and that will result in manufacture of sulfur trioxide. The resulting sulfur trioxide will be added to a reaction chamber containing ammonium hydroxide. So crystallization will occur and the solution will be transferred to a settler where the solids will be separated from the liquids. Now the solids will primarily be ammonium sulfate and they will be dried and ready for the market. Now we have introduced a recycle stage where we're going to recover water and also recover some excess ammonium hydroxide which will be returned into the process. In conclusion, our main aim is to get this toxic gas and convert it into a more useful and economic product. So we thank you for the opportunity that you've given us to present our idea, and hopefully it will be in play in the near future. Thank you very much.